Okay, translating functions with mapping notation. So here's our kind of our original function, okay? Y equals x cubed, which is a cubic function, and maybe we're not really familiar with drawing them. They essentially take on this look, okay? And if we're really unsure of any like coordinates, we can always build a table, right? We can always build a table and kind of run it through that equation in order to get values. Especially because in our question, though we haven't written it down, they asked us for 5 exact points in our new one. Well, in order to use the mapping notation to find 5 exact points, we're going to need 5 exact points from the old equation. So in the old equation, we'll do it in black and white here. You can really just kind of arbitrarily choose x values. We can go -2, -1, 0, 1, 2. What is that? Is that 5? That's 5. There you go. And these are really common ones to choose. And all we really have to do is plug them into our y equals x cubed, and we can quickly find values. We'll do it very quickly. -2 cubed, because it's a negative 3 times over, our answer is going to be negative. And then 2 by 2 is 4 by 2 is 8. Okay. Same idea of -1 cubed. Again, we'll get a negative. And 1 all over is 1. 0 cubed is 1. And then these are going to be pretty much, the absolute values will be the same, except that when we do a positive 3 times, it'll be positive. And when we do 2 3 times, it'll just be positive 8. So these are our original numbers. Okay, so we built that really quickly. Maybe you already knew what they would look like. Let's build what our mapping notation was so that we can actually extract our new coordinates from each one. We'll have to, and this will be the hard part, figure out what our a, c, d, and k are in this cubic function. So I'm going to go below here, and I'm actually going to write out our kind of parent function here. Y equals a of whatever the function is, bracket k, x minus d plus c. The function they've given us says y is equal to -x over 2 cubed plus 2. Okay, the c is pretty easy to pick out. Okay, that's our c. And our a value, which can look really confusing, but try to keep this in mind that k and d are within the function. Okay, that's why they have these brackets. So if this denotes what type of function it is, if it was square to be quadratic, if it was sine to be sinusoidal, if it was, what else do you guys use? Reciprocal 1 over x. Those are the things that stand out that tell you what type of function it is. So the variable's to the power of 3. So everything in this bracket here represents either a k or a d, and we have to figure out what it is. So outside of this bracket is where our a falls. Okay, so outside of this bracket there isn't a term, and because a is times it, it's technically the number 1, even they don't write it in. Okay, so our a value is actually 1 in this one, and that can be really hard to see here. Our d, we look for any addition and subtraction of the variable, and I don't have any addition or subtraction. I do have it being negative, and I'm going to extract that and show you how this is really all the k just kind of simplified. Okay, so our d value, because there's no addition or subtraction, the d value is actually equal to 0. And the reason being is you can add or subtract 0 and it doesn't really change anything. So I could write plus 0 in here, but I don't want to get it too convoluted. So really what we have left is a k. So this somehow is a k, and we need to figure out how this is a k. So I'll rewrite it again, -x over 2. Well, I'm going to go back to my fraction rules. These are hard to see what the k is. So I'm going to split this. I'm going to make the x a whole number, and I'm going to make whatever is in front of x. And do you know what number is technically in front of x here?
1.
1. I'm going to turn this into a fraction. So this is technically the equivalent of -1 over 2 times x over 1. Right? If I multiply across, -1 times x is -x. And 2 times 1 is 2. And that's how that simplifies. So now that I've extracted this out of it, I don't need to write x over 1. I can just write it as x. Okay, I'm going to rewrite the whole thing with -1 over 2 being the k function. Okay, it's kind of like it's multiplied by that. And then we have our cubed, and then we have our plus 2, and we have our multiplied by 1 on the outside. And of course, technically, we have plus 0. I'm just going to add that plus 0, which would normally be in that bracket. And I should do this properly for you, so let me show that. technically there's the plus 0 of d, and then that's all in that bracket, okay? Oh, I wrote d, I meant to write 0. Technically plus 0. So d is 0, c is 2, a is 1, and k, which is hard to see, is technically negative 1 over a half. Okay. Now, this negative 1 over a half actually is also difficult to put into our mapping notation. So let's write out our mapping notation below. Again, we said mapping notation is x over k. And I said minus d, right? And that's going to be, it doesn't make a big difference here. And in the other version, I said plus d, just depends how we extract it. In this case, d is 0. I actually subconsciously already wrote it in. I meant to write d there. Our a value is 1 times y, and our c value is 2. That's straightforward enough. The d is straightforward enough. The k is tough again. Negative a half. Well, I'm going to write that on the side again, kind of my side notes here. This is x divided by negative 1/2. That's very odd to look at. Okay, so I'm going to think of fractions again, and this is why they always stress being very strong with fractions. I can rewrite this as x divided by, because that's really what it says, negative 1 over 2. And then, okay, what are my fraction rules? Well, I'm going to make x a fraction, so over 1 divided by negative 1 over 2. And the rules of fractions is you invert and multiply if you're dividing. So it's x over 1 times 2 over 1. And again, it's still negative. And now we just multiply across, and we get negative 2x over 1, which is the equivalent of negative 2x. I'm not sure why I stalled there. Okay, so because that's negative 2x, and I kind of completed all of that, this is what our mapping notation would look like. It would say negative 2x plus 0. I'm not going to write it in because it doesn't change anything. And here we get y plus 2. So these are the only two major things that are happening to our mapping notation. So now that we know this idea, I'm going to copy it. Let's group it all together. Group and then copy and paste it up here. Okay, now that I kind of have this on top, we're going to make our next little 5 parts in our table. X and y, kind of squeeze it in here. Okay, so let's mentally put these numbers through this mapping notation. The y's will be pretty straightforward. Negative 8 plus 2 is going to give us, do you know what?
Negative 14.
It's just going to add 2. We're not going to, yeah. So it's negative 8 plus positive 2 will give us negative 6 in this case. Negative 1 plus 2 will give us positive 1. 0 plus 2 will give us 2. 1 plus 2 will give us 3. And 8 plus 2 will give us 10. So these are our new set of y's. And just make sure we put our x's correctly. Negative 2 times negative 2 will give us positive 4. Negative 1 times negative 2 will give us positive 2. 0 times anything is still 0. 1 times negative 2 will give us negative 2. And 2 times negative 2 will give us negative 4. So here are our new set of 5 exact coordinates once they've been put through the translation of that function. And we figured that out by using our mapping notation in this